theme of this course is to teach you some fundamental principles of how organisms fit into their environments. We will focus on two important dimensions, heat and water. We are going to examine these and to learn to measure them, and then try to make ecological sense of the data that we collect. To do so, we'll delve more deeply than you may be used to into the properties of heat and water and how these operate together and affect our measures of temperature and humidity. What we will learn applies to animals and plants, both big and small. We will begin by examining heat and how that relates to temperature per se. This will lead us into a very important quantity known as the operative temperature, which relates heat to temperature of animals and plants in a way that makes ecological sense. We will go on to learn about water and humidity and how these are related to each other and to temperature. As for heat and temperature, you must have a good understanding of what humidity is and what governs the relationships between water in the environment and the organisms in it. As you will see, we will place more emphasis on animals than on plants. That's our own particular bias because we are both zoologists. But what you learn can easily be applied to plants as well. We'll begin by discussing the fundamental relationship between heat and temperature with a demonstration first used by the American scientist Benjamin Franklin, who is credited with discovering this phenomenon. We will follow that with a brief discussion of the three laws of thermodynamics that enable us to connect temperature and heat. We'll then turn to temperature scales, how they developed historically, and what their relationship is to the thermodynamic temperature we defined previously. We will then connect thermodynamic temperature to the modern measures of temperature that we use daily. We'll wrap up this section by telling you about how heat does work, in a fact discovered during the 18th century and made the Industrial Revolution possible. This will be important in helping us understand the ecological significance of heat and temperature.